right, we're recording now. Welcome again to ECS CDM 12 Media Computation. Today we'll be talking about interaction. So what we see here at the top, this is, okay, I'm just getting the mic in place. This is the interaction loop. This is actually from the Game Field book by Steve Swink. This is one of my favorite game interaction design books, where it takes you through the loop, the interaction loop between you as a player, what you perceive, how you perceive it, the cognitive process that goes on in your mind that turns incoming photons into meaningful representations, how you decide on those, how you pick which actions to take after you recognize what's going on and make your decisions, how that decision transfers into electric impulses that move your muscles and motor skeletal system into reaction times, output, moving your muscles. And then the digital divide here, which gets turned into controller presses. You know, our meet interface adapts to the digital interface, controllers, keyboards, mouse, VR rigs. And that turns into signals that the computer reads and then processes. And then simulation ensues. Your code runs. And then it updates its internal properties, internal states. That warehouse full of boxes gets new values. And then you write the code that changes things on the screen, puts pixels in place, pushes sound through drivers, rumbles the joypad, presses buttons on the haptic devices and tactile vests. And then that is the border between the digital and the meat. Then you go back to your meat interface and do it all over again. We do this very quickly. And it's kind of amazing that we as humans can interface with these simulations in such amazing ways. There's an entire field of human-computer interaction that specializes just in this. And of course, there we go. We're going back to Schiffman chapter 3 for interaction. So that is the associated reading with this lecture. So interaction, let's put a little finer point on this. Let's talk about it a bit. Make your programs respond to the user or other events, right? Basically, we want to complete that loop. We want to have people interact, a user, a player, interact with your sketch, have it respond in some way that's legible to them, and complete an interaction loop. And processing's really good at this. It cuts out a lot of the boilerplate, a lot of the intermediary details, and gives you very salient, usable commands and functions and programming methods for you to interact with people. And we'll be going over several examples of that today. So please check out the interaction in the examples folder in the class materials Google folder. We have 6 examples to look at today. Less slides, more code. Event-based programming. So this sort of shifts how we've been thinking about processing so far. We've always been thinking about frames discretely. What do we do? How do those add up? How do we draw over this canvas, wipe it clean, add new stuff on top of it? Event-based programming is a little different. There are little processes running in processing, little bits of code that are sitting there in their own little loops just waiting for something to happen. Mouse press. You've used it a bunch of times to generate images, right? You open up the window, you click on it, it saves your image.jpg. Now, you didn't write a whole bunch of code to sit there and wait for the mouse, look at mouse state and just wait for it to change into a press. You simply wrote a function, wrote a command, filled it in with a block of code to do whatever you want, to have whatever you want to happen when the mouse is pressed. That's an event. Something is waiting for the mouse press to happen, and it generates this signal, this event, that then processing can read. And then when that event happens, it goes and looks at your sketch and be like, okay, is there a method here, a function, that has this particular name, mouse pressed? And if you have that function defined, it will call that block of code that you put at the end of that function. If you don't have that function defined, nothing will happen. This is the basic model of events. It's also a model for program organization. User input occurs, program responds to it. This could be a machine-driven event, right? This could be information coming from the World Wide Web. How many of you have played a multiplayer game? Right? Well, you're getting constant stream of network-based information that is triaged generally as events by your client, by your app, on your phone, on your console, on your PC, laptops. Those events work just like this. Something happens, read it, response happens. And events, as we've talked about, can also be input activity, mouse clicks, mouse movement, a video frame received, a key pressed. We have a lot of these events we could potentially use. There are a ton of them. Built into processing, there's a ton. And then there's a whole bunch of libraries you can include in processing to augment its capabilities that have even more. And you can think of these as callbacks. So when you write your mouse pressed function, these are bits of code or methods that respond, that are your defined response to when an event happens. Mouse pressed, save image. So often, you want to update state, perform an action, etc. When these methods happen, you define the response. The response can be just about anything you can program. Event examples we've seen so far. Setup. This is an event. The startup event. Draw. The refresh event. Mouse pressed. Save your snowman. Right, so you've been using these the entire time. We just haven't quite defined them or put a point on it yet. We left them as a bit of mystery. Mystery uncovered. And if you want to learn more about the internals of event-based programming, I'm happy to chat about those during office hours. We can make an event system from scratch if you'd like. Now, let's talk a little bit about how to maybe alter some of these events. Frame rate is a great one. So if you look at the processing.org's documentation, where it's a reference for frame rate, you can set the max frequency that draw will be called at. The default value is 60 frames per second, 60 hertz. If your processor can't handle it, your updates can be slower. They will never be faster. If you set frame rate to 60, it'll never be 90. But it can be less than 60 if your machine is struggling with keeping up with the computational load of your sketch. You're going to have to push your sketches pretty hard for a modern laptop to not run 60 hertz on a reasonable sketch we'll make for this class. This is more like when you're doing 3D rendering, ray tracing, photon mapping. Maybe you're doing a little bit of machine learning on the fly, online update, deep learning. Right? But you can change this value. 30 is a good value. 30 is above most people's perception for motion. We have a lot of, FPS, like frame rate, people that have like extremely high frame rates. 120 hertz, 240 hertz. It's kind of getting ridiculous now, the actual frame rate and update values of monitors. So you can adapt to those. You can adapt your program to work at 120 hertz or 240 for FPS. Just had to change that value. All right, let's look at our first sketch. Avoid draw. Ellipse mode center, fill 255, ellipse, mouse X, mouse Y, 2020. What do you think this does? Before we jump into it, before we see it. Close. It is a mouse event. Like we are responding to mouse input, but it's not quite when you click. Yes.
Does it just follow your mouse?
Yeah, it just follows the mouse. You're drawing the ellipse's center location, because ellipse has default center drawing, center mode by default. The ellipse mode is center by default, I should say. Keep it in the exact right order, and you're simply drawing it at mouse X, mouse Y. What else is interesting here? Let's see. So when I have these little boxes in the corner, this is the name of the example we're going to look at. So we're going to look at simple ellipse sketch. Let me open this up in the correct directory first. I have several different versions of this saved. So make sure we're looking at the same one. All right. So first off, you see some examples. I changed the color scheme. So we're actually working on a solarized color scheme because that came up in conversation the other day. You can see about the solarized color scheme here. It's a very popular one for code editing. So what we're doing is we have a setup function, setting size of the window, setting background color to this base 2 that we defined up here. Base 2 and blue are the two colors we're using. We're getting rid of the stroke value. And in our draw, ellipse mode center, fill blue, ellipse mouse X, mouse Y 2020. So basically the same as the sketch we saw on the slides, with some color changes and some cosmetic or some visual updates. Right, doing some basic drawing. Is this what you expected to happen? Notice that we're not calling background anywhere in draw. So we're not actually refreshing our screen. We're not drawing over it again. So everything we draw is just going to stay.
So if you put background in the draw method, it will like refresh everything.
Exactly. This keyboard. The big deal with this keyboard is I keep pressing the mouse pad's very sensitive and it's easy to touch when I'm typing up here. Background, base 2, Control S to save, Control R to reload. Right, now it's just basically drawing the mouse. So I'll put that in here in quotes so you can play with that later. All right, does that make sense? Any questions on this? Yes.
I'm sort of curious what it would look like if you set the frame rate really low.
The higher the frame rate, the more continuous the line is, because we're drawing much more often. I'm going to take that out of this example. I don't want to confuse anyone quite yet. Yes?
Did you define what base 2 is somewhere?
I did. It's the very top. Let's see it again. These are just two colors that I picked from the Solarized color palette, which you have a link to right in the comment.
Okay, thanks.
You're welcome. All right. Back to the slides. All right, so it's simple sketch. What's some shortcomings of this? Right, well, we don't have a lot of control over this, right? We're not actually using events explicitly yet. We're using draw, right? So we're not actually being interactive in deeper ways. We're just simply drawing where the mouse is, drawing mouse position, right? So we can't start or stop the drawing. We can't make continuous lines. We can't erase or clear. We can't change the color. Right, so let's maybe build up to some of these. Connected lines. Let's add a couple more variables. P mouse X, P mouse Y. These are actually the locations of the mouse on the previous frame. So you know where you were and you know where you are. So we can draw line instead of mouse X, P mouse X. Instead of mouse Y, P mouse Y. And then we can draw a line from where we were to where we are. Mouse X, mouse Y. Shall we take a look? Oh, we don't need that snowman in there anymore. Deleted. I said deleted. All right, sometimes my machine chugs a little bit. This is an older laptop. I have a purchase order for a new one coming in. All right, let's look at the code. So we're using Solarized again, base 3 in green. 800 by 800 window, background is base 3, stroke color is green. Void draw. We're using P mouse X, mouse Y, mouse X, and mouse Y. What do you think is going to happen? Any thoughts? Yes. Yeah, right. We're connecting a bunch of little lines together based off the previous current location, so it should have a much more fine following. Right? We're just drawing a bunch of lines. So now we have more input, right? We're following the line where we have more continuous drawing, independent of frame rate. Let's look at a variant. Let's draw some happy little fan ferns. So what's going on here? Yeah? Exactly. Yeah, so we are just drawing from 2020 to the current mouse location. Right, and this gives us some effects. Now we're drawing from this central point, from an origin. And you can see we can do some interesting things with it, like draw fans, or these shapes that kind of can be interpreted as like a 3D curled bit of paper. Yes?
Can you draw to the extent where your system crashes?
Not in this example.
Okay.
Because we're not drawing a bunch of lines and saving a bunch of line information. All that's happening is you're drawing a line as changing a pixel color. So if you see the window as just this big like 2-dimensional array of individual values, you're just updating those values every time you draw. And so you're drawing over it, drawing over it, drawing over it. You can do this a lot of times. You can have this on all day, and there won't be a bunch of like extra memory or a bunch of boxes being taken up in your warehouse. Just the amount of boxes enough to represent the window. You have a bunch of pixels in a grid. Each pixel has a box. You're just changing the value inside those boxes. You're not adding new boxes. Does that make sense?
Yep.
Excellent. All right, so that was our first line sketch, or a variant of our first line sketch and a variant of. So processing supports many different types of input. I would go take a look at the input reference section for this. Let's actually just maybe take a peek at that real quick. Processing.org. Let me load up the website. Okay, so let's just show you what I'm looking at. So this is the processing.org/reference. You have a link to this in the syllabus. You look at input. You can see we have a whole bunch of things for input. You can input files. You can look at the time and date We'll be looking at millis later. You get keyboard from the input, key pressed, key released, key typed. Here's all the mouse things we're talking about. Button, clicked, dragged, moved, pressed, released, mouse wheel, and then the locations. Here's mouse X, mouse Y, and P mouse X and P mouse Y. These are all the native capabilities that processing gives you for free. So the important ones we'll look at that you'll be using pretty regularly with mouse are clicked, dragged, moved, pressed, released. Variables are mouse X, mouse Y, P mouse X, P mouse Y, mouse pressed, and mouse button. I would take a look at all these. These will be very handy for you. How can I make it only draw? How can I make it only draw when I want it to? Well, you can use the mouse to click to put the pin down. You can click again to release potentially. You can move drawing code to mouse dragged. So now you're only drawing when you drag a mouse. Hi. Well, there's someone peeking in. Why not use mouse pressed? Well, dragged does the work for you, right? Why recreate the wheel? If you draw when you do mouse pressed, you actually have to hold down the mouse button to continue drawing. When you release it, it stops drawing, which can be what you want, but can be a little tough. Let's take a look at line sketch click. All right, once again, we're borrowing from the Solarized color palette. With this time window is 600/600, background is base 3, stroke is cyan. We don't actually have anything in draw, but on mouse dragged, we have our P mouse X, P mouse Y, mouse X, mouse Y code. Right, so now I'm moving around, nothing's happening. But when I press and drag, now I'm drawing. I can stop drawing. You can sketch things. As much as you can sketch on this tiny little mouse surface that's tilted, you have an affordance here. Now we can draw, release, draw, release. We can express ourselves. Any questions on this? Yes.
It's not a question about the drawing, but you have stroke cyan. Is there a list of colors where we can just write the color in instead of like, oh, okay.
Yeah, I got these from the scheme. So if you want colors, there are a ton of really good color palettes on the web. This is one I like. I search open source color palettes, and you can find a bunch of just really good information, and they have these values that you need. You can like look at the ones that are pleasing to you. I usually pick a lot of these for my papers that I write to make sure all the diagrams are like cogent, coherent. There's just some really interesting color palettes. I've been really liking Goldfish recently, which is a very saturated color palette. It doesn't have, it has a bit of an off-white, a bit of as the base, and then it has a very bright, vibrant gold, a very bright, vibrant blue, and then a bright yellow. Did you find Goldfish?
Yes.
Yeah, I love Goldfish. Yeah? Is that a question or a stretch? Okay. Right, so that's where I got these from. Nothing in draw. You can even, maybe you can remove draw. Let's see. Yes, we work without draw. I thought that would be the case. But now we're actually hooked up in the input system. So draw is actually necessary, it looks like, to kickstart using events. right, so that was line, sketch, click. We have keyboard events. Mount, key pressed, key released, key typed, key code, key pressed. Look at the documentation, all these. We'll look at an example here. These are very handy. You can do full text typing if you want, if you put in enough events. There's libraries that you can actually download that'll do console controller events as well. There's VR hooks. There's libraries that will give you similar methods for VR rigs, even motion capture. Let's have a little bit more agency and control. Let's be able to change our brush on line, sketch, keys. We'll press 1 for blue, 2 for magenta, 3 for green, C to clear the palette. This will be a little more code than the previous ones, so we'll spend a little time on it. Make it a little taller. Great. So we have some more colors to work with. Base 3 will be our background color. And we'll draw magenta, or blue, magenta, and green. 1, 2, and 3. We up the stroke color just for fun. I think it's a little bigger. We have our normal mouse dragged event, just like previously, just like the previous example. And now we're having this key pressed event. Now what happens in key pressed is it'll detect whenever you press down a key. Right, so this key pressed down, and then so if you press it down, that one frame, you'll have a key press event. If you hold it down, then that will be key pressed, that will be firing. When the events will be set to processing. And then when you release it, there'll be a key press up. So there's key press down, key press up. So you can handle all sides of that interaction. So when I press C, we're going to call background again. Set everything back to base 3. 1, we'll set the stroke to blue. 2, we'll set the stroke to magenta. 3, we'll set the stroke to green. Now this key value is something that key pressed gives you. This is something built in. This will be, when a key is pressed, that will be the actual key that was pressed. That value will be given to you so you can compare. So we have conditionals. And this is how you can compare a single character to a variable. Key, double equals. So conditional to see if the left-hand side is the same as the right-hand side. So we're seeing if that key variable contains the value C. If so, background. Else if, so we'll run this one first. If this is true, we'll set background and then ignore the others. Then go on. So this is true. If this is true, ignore, 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 ignore. And then you'll start running after this curly brace. And there's nothing there, so the function's over. Block of code is done. But if the key is not C, but the key is a 1 instead, you'll stroke blue, ignore the rest. If key is 2, stroke magenta, ignore the rest. Key is 3, stroke green, ignore the rest. This has no else. So if none of those keys are pressed, if you press any other key on the keyboard, there will be no change. With the exception of pressing escape, which will close your window. All right, so it starts off with the default stroke color. Black. I'll press C. Cleared. I'm going to press 1. Good blue. Press 2. Magenta. Three. Green. One, two, three. We'll destroy all of our hard work. And draw some more blue. Let's see. What's a fun thing to do with blue? Okay, the sky. All right, that's bad. That's bad. The sky. And then let's make We'll go 3 with green. Make a little bit of grass. Happy little tree. Maybe not so much a tree. Whatever, it's very hard to draw with this mouse. Need my pencil. It's a frog creature that shoots lasers. This is like very World of Worlds, right? It's like a tripod creature coming down. Yes.
If you wanted to manipulate the stroke weight, is there any command to just kind of use that as a, I don't know if we would explain it, so as a slider, or would you just have to put stroke 5 if you push this key?
Yeah, sure. Let's else if let's see what key should we use? Else if key equals we'll do the minus. Then we'll do let's actually set a variable here. Int, I guess, float stroke weight equals, we'll set 10 as the default. I'll set stroke W. I don't want to conflate our variables. What's going on? There we go. Stroke W. We'll set the default value to stroke W. When we have minus, stroke W, and we'll look at a different math right here. So normally you do stroke W equals stroke W minus 1, right? There's a shortcut for this. This is the same as doing stroke W minus equals 1. So you save a little space. We're drawing. Oh, let's set it a color. We're drawing, we're hitting minus. Oh, you know, we need to update the value. So we want to make sure that value is updated. So we're going to, every time mouse drag, so this will only be active when we drag the mouse. Actually, we'll do 2 versions of this. So now if I push minus, it shouldn't be updating the stroke value, but now I'm drawing negative width. Okay. So we can't be negative stroke values. Okay. If stroke W is less than 0 or less than 1, we'll keep it minimum, then stroke W is 1. Right, so this is a little guard. So if we go too low in our stroke value, lower than we want, we'll just set it to the minimum. We got tiny. But now we're stuck tiny. Should we add support for making it bigger? Let's do it. Else if key equals, and we'll do the equal sign, just so we don't have to do shift for minus and plus, we'll do dash and equal on the keyboard. Stroke W plus equals 1. So now when you run this, we can go with blue and make it tiny. Then we can make it huge. Humongous. Oh my gosh, stop too big. Clear. Plus. Drive you all crazy. Let's color it all in. The 1 pixel left. All right, so you can do a lot of things with this, right? This is really easy to extend and use and do what you'd like. Any questions? Anything else we should add? Yeah.
No, like in processing, we don't need to like add the else at the end of the else statement. So we can just like keep adding else every time.
Yeah, when you make a conditional, the only thing that has to be there is the initial if. All the else ifs are optional, and the else at the end is optional. You're welcome. Yes.
So with this line of code that you made, are you able to bring the stroke weight down
Yeah,
a bit too, as well? Okay.
that's the first thing we did.
Okay.
The minus sign makes the stroke weight, reduces the stroke weight by 1 every frame that you're dragging. And we had an error because it quickly went negative, and processing cannot handle negative stroke weights. It just sort of flagged an error. So we put in a little guard. We put in a minimum here, which is this if statement at line 48, 49, and 50. So if the stroke weight goes below 1, we set it to 1. Any other questions? All right. So we talked about this. There's tons of different types of input: mouse, keyboard, Kinect, video camera, environmental sensors, light sensors. I know. It'd help if I actually switched it back to the presentation, wouldn't it? There we go. Mouse, keyboard, Microsoft Kinect, which was a really cool device. I'm really sad they discontinued the Kinect. It was a very inexpensive, very cool bundle of cameras, infrared cameras. Voice sensors, had a microphone array so it could do directional audio and find multiple people talking at the same time. It was just this really fun thing for research and to make art with. So that's why I leave it on here. Video camera, environmental sensors, light sensors, just about anything that can send a stream of data. You can use that as a source of input. You can do interesting things with it, right? Eye tracking, mouse clicking, color change, all this stuff. The sky's the limit. Your imagination is the horizon. Let's look at a couple more examples. Interpolation and stare at. First, we'll start with interpolation. This will involve some math. We're going to get a little mathy here. I heard the groan. I understand. But this is the way of programming. No, line sketch. Yeah, sure. Let's keep those changes so you can see those. Interpolation, right? We're having a variable frame count. So, just like we did last class, we're going to count frames. And we have a variable called start and a variable called end. We'll use those later. Nothing special in our startup. Size is 800 by 600. Draw. So, first thing we're doing is every frame, we're setting the background color to white. We are having a variable called cur. We're keeping that for current value. A duration, and a start frame. Let's see. Right? So we have two options in this code. We'll look at the first. So option A, this code is active right now. We'll talk about it. Option B, you can delete the block comment section around it to use it instead. So what are we doing here? So this is classic interpolation. So interpolation is starting at one value and then moving slowly or moving regularly to another value. Well, what controls how you move between those two spaces? Well, that's the t value. It's a value between 0 and 1, where 0 is the left-hand side. 1 is the right-hand side. And then as you increase t to 0.1, 0.2, 0.3, 0.4, 0.5, you get, when you go to 0.5, you're at a value halfway between the sides, the limits. 1 is all the way to one side, 0 is all the way to the other side. Okay. So how do we pull that off? Well, here we have, when our frame count is greater than start frame, right? So looking at start frame, 200. So we're actually going to do 200 frames before this if statement even fires. So this if statement will start at 200. If the frame count is less than duration plus start frame. So what does that do for us, right? So that's actually the end. So we start at 200. But we want to end when frame count, or we want to do this animation, process this t value when we're between 200 and start frame plus duration. Start frame was 200, duration is 100. So between frames 200 and 300, we'll be in this if state. We'll be adding our t value. And when we go to the right of it, we'll be at 1. So we're just going to go between 0 and 1 from frames for the 100 frames between 200 and 300. So if t value is 0.5, we should be at frame 250. This is also called normalization, where you're taking a range of values and mapping it between 0 and 1. It's very handy from everything from tweening in animation all the way through normalizing a distribution space for nodes in for weight values inside of a neuron in a neural network. Normalization happens all the time. It's good for vector math, great for games. Right, any questions about this? I guess we should talk about this too. Line 40. This is where a lot of the work happens. So we're taking our current frame count, which we're in here, it should be between 200 and 300, minus start frame, right, which tells us how many frames we are in between 200 and 100. So if frame count is 250, minus start frame, which is 200, we're getting a value of 50 here in this parenthesis. And we're dividing by duration, which is 100, right? So we're getting 0.5 as t, right in the middle, as it should be. If we're at frame 275, frame count with 275, start frame is 200. 275 minus 200 is 75, divided by duration is 100. Duration is 100, so we get 75 over 100, 0.75. Hey, look, we're 3/4 of the way between the start of our interpolation and the end. And so we're looking at this t value, and we're getting our current value of where we should be. Our current value is 1 minus t times start plus t times end. So let's see how this looks. Counting up to 200. Here we go, 200. And we're changing some values. In 1, we're mapping the position of the left circle to that t value, so between 0 and 1, or between a mapping of locations to other locations, from a left location to a right location, from 0 to 1. And we're also changing the color, the grayscale color of the fill, from the 0 being black to 1 being white. I'll show you that code in just a moment. Just take another look at this. Frame 0, counting up, counting up, counting up. We're at 60 FPS, so it should take a little over 3 seconds. And we have a 100 frame animation. We're getting 60 frames per second, so the animation is like close to 1.5 seconds, a little shy. So here's the drawing. We have 3 lines of drawing that take care of this entire thing. We have the ellipse. The current value that we calculated is the left-hand side, is the left location of the ellipse, and it's set to 200 in the y location, 20 wide, 20 tall, 20 width, 20 height. And our fill command is cur, meaning we're going from a value of 0 to a value of full white. And then we're drawing another ellipse, which simply will take that fill color. And then we're adding 1 to the frame count. One more time. There we go. And you can see the values at the bottom as they change. So the left value here is the t value that we calculate, and the right value is what that color is mapped to a number. That's our start and our end, 0 to 255. Let's see these values change as we go. We're waiting until frame 200 for this to start to go upwards, and then over 100 frames, we map 0 to 1 to 0 to 255, normalize it, and change the values. Now I'm expecting that you'll need to take a look at this, think about it a bit, read through the code, and then we'll talk about it more. This is something you'll want to digest a bit. This is something that's going to be very handy when you start doing animations and more detailed interactions. And then this is the basis of stretch, like the basic Disney animations: squash, stretch, bounce, move. All of those are sort of based off this interpolation. We had two hands. I'm not sure who was up first.
I was just going to ask if we're able to see these examples of the lecture and stuff. Are they in the slides or like accessible to us?
Oh yeah, they're in the Google Drive folder for materials for the class. We have a whole example subfolder, which have all the examples we've looked at in class, plus some more. And today's examples are in the interpolation folder. Are in the interaction folder. The other I word we're talking about today, interaction. And all these examples that we went through today are in that interaction folder, and they're in subfolders. You're welcome. Great. Now let's look at the other option. So let's comment this one out. Oh, sorry. And comment this one in. So let's look at the comments that we have here. So this first one, option A, this method introduces parameter t to the interpolation between two values. The result is stored in cur. Here, the method calculates the value in the variable directly without using an intermediate variable or an extra box called t. And the result is stored in cur. So we're doing the same thing, but without t. T is implicit. We want to explicitly show you t. A lot of times, in effect, people who write animations, who write this code, who do a lot of processing and want this sort of interpolation, will bake it in. They won't explicitly make the t, but they'll do the math around it. Right, so example here at line 68 is the same as this line 40, where we're looking how far we are given the duration, so we're calculating the t value. And line 49 here, where we're explicitly using the t to find where we are in the cur value, to find our actual current value. That's line 71. All right, just to take a look. Same thing. Just one's a little more compact. One explicitly does the interpolation math and normalization. The second one bakes it in. So two code examples for you to work through. Any questions on this? I know Sucker's pretty. So I'm intentionally going through code examples that should be on the low end of experience for you coming in, like the mouse press, like whole 10 lines of code for that. Hopefully everyone in the class should understand it. And I'm intentionally introducing more complex code for those of you who want to push things a little farther. I want to give you like another bar to reach for, another ring. All right. Let's take a look at stare at. All right. So we have some variables about right eyes and left eyes. We have a shift value, some base color, some incoming colors, a P image, IMG. That's one we'll cache out fully when we talk about images and video. But I'm just using it now so you have a small example. Size is 800 by 1000. Background color is white. Rect mode is center. We have a Wikipedia Commons image with this string. Our draw command, we're setting the background color to 255. We're actually drawing the image which we denote here, which we've loaded here, at location 0, 0, and it's going to be 800 wide, 800 tall. Now we're using some normalization here. So here we're getting the distance between the right eye and left eye in our mouse position. And we're getting a ratio and a shift value. You'll see what this will do in a moment. And so we're moving the radius, the center of this right eye and left eye based on their nominal center positions, their default center positions, and the distance in the mouse X and mouse Y. Doing the same thing for the left eye. Then we're filling, and we're drawing ellipses with these new right eye, left eye values. We're also using mouse distance, doing a little calculation here, where we decrement base color and put a floor on it so it doesn't go negative, just like we did before with drawing. And we're doing a little fill, so we'll know when the mouse is pressed. We'll do a little rectangle, just so you can see exactly where that value is. And we're drawing that rectangle of mouse X, mouse Y, close to black. We're getting stared at. And a little angry when you bonk her in the forehead. Oh, I'm sorry. I forgot to put in the magic incantation. Let me get that line of code back. Apologies, I messed that one up. Yeah, I can see where that would be very confusing. We'll fix it. Got the line of code from another sketch, plopping it in. There we go. It's a little cross-eyed. You can click. That happens, but if you flick her on the forehead, she gets mad. So what this sketch does. There's no way to make her unmad. Yes.
Is there a way to have the mouse not show, like the mouse icon? Is there like a line of code where you can...
Oh, there might be. Let's see if there's a no cursor. Let me look real quick. Sets the cursor to a predefined symbol, makes it visible if it's already hidden. Aha! Okay, now I have no idea where my mouse will actually be, but we'll try this out. Wait, what? Okay. No cursor. Let's see if this works. No cursor. But, okay, so now I guess I have to decide. So down here, I can tell where my cursor is by where she is looking. She needs a name. Right, so there's actually a circular area that's right around here at the center that goes up to about here and down to about here, like a 200 pixel radius circle from the middle of the forehead where anger will occur. That anger is what we're calculating actually right down here. This is why we're doing a distance between mouse X, mouse Y, 420 to 60. 420 to 60 is the center of that circle. And if the distance between the mouse X and mouse Y and this point is less than 200, we're bumping the base color down a bit. And this base color is set to 255. Right, so this base color that we're setting, we're actually decreasing. Where did I put the stroke? Oh, here's the fill. Right, so the base color here is 255, base color, and as that goes down to 0, the green and blue channels, portions of the color, go down to 0, which just leaves the red. So going from black to red. Oh, sorry, to red. Black to red. There we go. right? So we have all this keyword input, right? That we used in the other example. So you could do all sorts of input with this. You can make this like a fully interactive virtual avatar. You could make your own VTuber avatar right here. A little zombie-esque. All right. Any questions? Yeah.
If you want to import an image, you have to probably download it first, right? For it to...
Yeah. So that's why there is, if you look in the project folder, let me open this up in the media computation. I'm opening up in a web browser. One moment, I'll switch to it as soon as I get it in the correct place. So this is in our materials. Okay, now I'll flip it over to browser. This is your materials folder. We have the lab and examples. Examples, lecture 4. I'm sorry, not lecture 4, interaction. I started naming them after the topic instead of the lecture number. Stare at. And you'll see there's our PD stare at with a lot of code in it. And then here is a PNG that we're loading. Questions? Yes.
How do you directly put it in, like the PNG into the photo?
We're going to cover that in detail later in the course, but I'll give you a quick brief right now. So first, you need to make a box to hold an image. That's what pimage is, the pimage class. So like int, float, pimage is another way to say, hey, make a box. Right now, we're making a box with a label. It doesn't actually point to anything on the shelf yet. There's no image associated with it. It's an empty box. Now, we're taking our image, and we're using the load image built-in function of processing, which will look in the same directory that your PD file is. It'll look for images. It'll look for an image with this exact name. Both caps and the extension have to be exact. And then it'll load the image. If everything goes well, it'll load. You won't get an error. But that hasn't put it on the screen yet. If we don't put it on the screen, you use the image function, the image command, which takes an image as the first parameter and starts the image top left at these 2 coordinates and sets the image width and height to the 3rd and 4th coordinate. So you can have images of like whatever size that they come in, like 19. This could have been in like a 1920 by 1080 image. And then we would squish that down and squash it into an 800 by 800 box. Yes.
Why is what is the image centered around? The top left of the image then? Or
The image center is the top left, or it's draw mode top left.
Okay.
Draw mode normal.
So it's like having rect mode, like corner, or...
Exactly.
Okay.
Yeah.
Could you then do like image mode center? Is that not
That's a good question. I haven't looked at the image mode commands. We can take a look at that and chat about that soon. That'd be a good office hours topic. Any other questions? Yes.
Is it possible to separate mouse into like left click and right click, or is it just like one click?
Yeah, you can.
Earlier you mentioned like you can't make your eyes go back down. It's like we go like left click make it go up, right click go down.
Yeah, let me see if I have this example still. Tools, recent, let's see. I need more recent. Let me take a quick look, see what I have. I have a lot of examples in process to show for the class. I haven't given you everything. Okay, we'll look at the Constellation Creator. This is something I'm working on. It's not done yet, but we can take a look. It'll show some other things off. So let's get rid of stare at. Goodbye. You were fun. We're going to do something else now. So stare at, or for Constellation Creator. Let's just take a look at what it does. I'm clicking a bunch of places. Then I right click.
Oh, it's not showing again.
Okay, because I didn't do the thing. There, I did the thing. Wasn't done yet. Was not fully baked. So I'm clicking around a whole bunch and a bunch of points on the night sky with no stars. I'm right clicking and we're making a constellation. How do we do this? Clear the screen. Oops, not exactly what I intended to do. Oh, I connected the ends. All right, so how are we doing this? Well, we have mouse pressed. And mouse pressed. Get this out of the way. We're in our mouse pressed event, and we're using the variables, the boxes that processing has preloaded that we talked about in the lecture slides that you can see in the input documentation for processing that we looked at previously as well. Mouse pressed. So if the mouse is pressed and the mouse button is left, so this is a variable box given for you, and this is what we call a constant value. This is a predefined value that does not change, and it is set to the value of mouse left when the mouse button left is pressed. So this is a conditional, right? So if mouse is pressed, that's a true or false value. And if the mouse button is left, is the value left, so this could return true or false. This could be true or false. And so we want to make sure that both are true. If both are true, we run this block of code. So we're printing left, which you could see down in the console when it was ran. Left, 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 left. And when we press left and we're not in drawing mode, we want to start a new constellation. So we set drawing mode to true and we create a shape. This is another thing like in the same set of functionality as rect, ellipse, line. You can start creating a shape, but you get to define what all the points are in the shape. So we're doing constellation begin shape. We're calling this new shape, make a new box for it called constellation, or I guess we're updating constellation box with a new set of shape values. We did define constellation at the top. It's a P shape. P shape box. Heart shape box. So we're saying, hey, shape, prepare yourself. We're going to start filling you with information. And if drawing is true, while we're still in left click, we give the constellation a point, a vertex. It actually doesn't need to be P mouse, it should just be mouse. I'm not sure. I was playing around a little bit. There you go. So we're giving a vertex of mouse X, mouse Y. And then we were setting the last values. I was going to use those, but I don't think we actually did. Otherwise, if the mouse button, the right mouse button has been clicked, we'll print right. So what happens? Well, if we're drawing, we say, hey, stop the shape. If we're not drawing, nothing happens. And we set drawing to false. So drawing mode won't start again until we start left clicking again. All right. So we have a drawing now. We've right clicked, drawing is false. Now it's left click. Okay, well, left click, reset the drawing. We're not actually drawing it, so the background color is wiping everything. So when we're not drawing the constellation shape. Left click. Drawing is now set to true. And we've already entered our first vertex. 2, 3, 4 vertices. Now I'll right click. Right click. Printed right. we were in drawing mode, so it stops this shape and makes sure that we have a fully formed shape. It says drawing mode to false, right? So now if I right click, nothing happens. But we had 1, 2, 3, 4 vertices. The shape automatically loops the second vertex, or the last vertex to the first vertex. So we get an hourglass. Left again. Some scramble. Right, so this is an example that I can, I guess, finish. Maybe I'll just give it to you in this form and then snazz it up later and call it even more better Constellation Creator and release that to you when it's more better. Any questions? Do a lot of code at you today. How are you feeling about this? Feeling good? I mentioned we'll have a range of thumbs up, yay, this is awesome, and a range of, whoa, what was this t value again? Oh, we're doing gladiatorial stuff. what will the emperor say? This code is deleted. All right. Well, we got 2 more minutes. Time for any last questions? Yes. Oh, 1 then 2. Yes, you're 1.
When is the next assignment going to be open, the next project?
Well, we'll take a look at the schedule real quick. All right. Browser. All the examples are in the course material drive. We talked about syllabus. Contains the schedule. If it loads. All right. So we're going to give A2 out. I'm going to push this back a little bit. I think we'll give it out soon. Probably do it next week. We're a little behind since we had we were down 2/3 of our TA loads, and we're button grading. So we may actually push this back 1 week and then give you the if conditional ones next week. So this will change. We'll likely have it be due not on a Wednesday. I may give it out by the end of the week and have it be due next Friday, is the likely course of action. Thanks for asking the question. Yes? No. That was something I didn't quite have finished yet, so it was still rough, right? And so I didn't give it to you, but I'm going to give it to you now. I'll put it in that folder for you to see. All right. Enjoy your Friday, the rest of your Thursday. Enjoy your Friday. We'll have fun reading through your assignments and expect assignment 2 soon. There will be a Canvas announcement and corresponding Discord announcements.